Welcome back to another deep dive. Today, we're tackling a question that really makes you think differently about renewable energy. What if your solar panels could generate electricity without sunshine?
Exactly.
We're diving into this, well, pretty fascinating innovation, rain-powered solar panels. And we're looking at their potential specifically somewhere like Virginia.
Right.
Our mission today is to unpack how this dual energy thing actually works, what it means for energy reliability, keeping the lights on, and also the balance, the benefits versus the current challenges. We're basing this on a really detailed article from Black Knight Power looking at their research.
And what's so interesting, I think, is how it tackles that fundamental issue with solar, doesn't it?
Yeah.
What happens when it's cloudy or raining?
Mm.
This deep dive, well, it shows a path towards more consistent renewable power,
Mm.
which is what everyone's looking for, really.
Okay, so that's the big picture idea. Let's get into the mechanics a bit. Black Knight Power's research talks about this dual system. You've got your traditional PV cells, photovoltaic, converting sunlight.
Standard solar part.
Right. But then they integrate something called triboelectric nanogenerators, TENGs,
Yeah,
for sure.
DTNs. And tribo, that comes from the Greek for rubbing, basically friction. It's quite clever, actually. These panels have this special layer, it's a sort of grooved polymer, right on top of the normal solar cell.
Okay.
So when raindrops hit it, the friction between the water sliding over this specific surface, it generates static electricity. Like rubbing a balloon on your jumper,
Mm.
but much more sophisticated and efficient.
Okay.
And that charge gets captured and turned into usable electricity. So you got sunlight doing its thing and raindrops doing their thing. It's this dual mechanism, more efficient, more sustainable, potentially.
And that ability, that consistency, that's really the key, isn't it? That's why it feels like such a potential game changer.
Exactly.
Especially when you think about Virginia. You mentioned cloudy days, but Virginia gets, what, about 44 inches of rain a year on average?
Hmm.
Plus, it's prone to hurricanes, those big weather events.
Absolutely. That consistency is crucial. Think about a week of just gray, drizzly weather, your standard solar output tanks.
Yeah.
But with these, you'd still be getting some power. Maybe not peak sun levels, but something.
Right. Now, the article does mention cost. It's not quite the same price point yet.
No, it's higher up front. They estimate maybe 20% higher than traditional panels.
Mm.
So
Sure.
maybe $2 to $3 per watt, roughly.
Yeah.
And that means a longer payback period compared to the 7 to 12 years you might see for standard solar.
Okay, so that's a factor.
It is. But you're trading that higher initial cost for enhanced reliability. Getting power during those wet seasons or just generally overcast days, that's a big deal for energy security, keeping things running when the sun isn't playing ball. Essential services, homes, everything.
And this is where it gets really interesting for me thinking about existing setups. Like, take North Stafford High School. The article mentions they have, what, 3,300 panels?
Yeah.
Generating 1.8 megawatts.
Yeah, a big installation. Saves them a lot over time. The estimate was like $2.8 million over 25 years.
Right. So imagine adding this type of panel there or integrating the technology. It wouldn't replace the solar, but it would complement it. Generate power when the existing panels slow down because of clouds or rain. It turns that weakness, the weather dependency, into less of an issue, maybe even an opportunity.
It does raise that important question, though. What does this really mean for the future? We've got the plus side reliability, but we also have those challenges. The cost we mentioned, tech availability, it's newer tech, not scaled up like PV yet. And then there are regulatory things. Frameworks for community solar might need updating for these kinds of hybrid systems.
Sure, the usual hurdles for new tech.
Pretty much. But despite those hurdles, the potential is significant. Better reliability, easier integration maybe down the line. It could really help a state like Virginia become even more of a leader in sustainable energy, going beyond just sun power to, well, all-weather power.
So wrapping this up, what does this all mean for you listening? I think it really encourages us to think beyond just sun only for renewables. This deep dive shows how innovation can take something we see as a negative for solar rain and actually turn it into an asset. It kind of makes you wonder, doesn't it? What other natural elements are out there just waiting for us to figure out how to harness them for clean energy in ways we haven't even thought of yet?